Okay, so in this talk, we're going to give a little bit of an overview of the course, explaining the contents of the course, what sort of things it's going to cover, the resources that are available, to you as you study for the course, and the assessment, the sort of coursework and the exam, and to just give you a little bit of an overview of that. I'm going to give you very detailed, talks on each of the pieces of assessment anyway, but this is just a little overview. Okay, so course contents. So it's a course on internet scale applications and their development. What I mean by an internet scale application is an application that's built using internet technologies such as TCP/IP, HTTP, cloud computing, and so on. Internet scale application, will run across multiple machines. It runs across the internet, or it runs on a large scale across the internet, let's say. And there's potentially a large number of users, large amounts of data processing, and so on. So some examples. So we've got these big websites. Google's absolutely massive website, Amazon as well. We've got online games, EVE Online, Grand Theft Auto Online, these kinds of things. Peer-to-peer networks such as BitTorrent, Freenet, Tor. We've got financial trading systems, cryptocurrencies, or things like that have CPU sharing, like Boink, or malware, or also another tens of thousands of machines running together, coordinated by attackers. And we got things like an Internet of Things is another example of an internet scale application. So this course aims to show you and explain how internet scale applications work. You'll get some practical experience developing internet scale applications, not on an internet scale, but you'll be using the sorts of technologies and sorts of approaches that are found in real internet scale applications. And you're going to have some great fun with mini projects, right? Personally, I really enjoy programming, putting things together. So in my view, you can have a lot of fun with these mini projects. You might not entirely agree with me about that. And also important, you're going to gain a set of useful skills that are very relevant to the commercial world. Most big-scale commercial companies are running their own big-scale, websites or other internet scale applications. So the outcomes of the course. So when you've done this course, when you've successfully completed this course, you'll have, some knowledge about the architecture of internet scale applications, how different ones work, the performance versus cost, trade-offs, all this kind of stuff. The technologies that are used, you have sort of intellectual knowledge about that, but also first-hand practical knowledge. You have some first-hand experience with cloud data storage and some understanding and knowledge and understanding of data processing, and some knowledge and understanding about the security, privacy, and legal issues surrounding internet scale applications. The sorts of technical skills you'll gain are first-hand experience with things like web services, sockets, cloud data storage, and practical experience building website with web services, an online game based on sockets, or some other technology, depending on your choice about that. You'll also gain some of the sort of people skills, I suppose you could say. You'll be able to communicate with groups of people. There's a class presentation included in this course, a little bit of practice with that. There's a group project included in this course, so you'll get some experience collaborating with teams that are not of your choosing. And you'll have the ability to develop internet scale application, which is a pretty handy graduate skill. So the various jobs you could have, if you assiduously worked hard on this course, then you gain all the skills that I'm trying to teach you on it, then you could potentially get these sort of jobs. So Java web developer, that sort of thing I did at Trinity Mirror. There's some pretty well-paid Java web developers. App developer, again, you're maybe using web services, all this kind of stuff, like the front-end technologies maybe as well. And you use game programming. That's quite a specialized job, but there's plenty of sort of softer game skills, in terms of building apps for games and websites for games, this kind of stuff. Big data analysis, we've got a section on distributed data processing. Or if you don't really enjoy the programming or the technical side, then there are jobs where it's useful to have some knowledge and understanding of it, but you're not necessarily applying it on a day-to-day basis. So if you're a technical recruiter, let's say, it's very good to understand the technologies that you're recruiting people for. So this course will be handy if you decide to go in that route. I think it's quite well paid. They've got massive commissions, I think. And then, or IT manager, right? Again, if you're managing people who are doing IT jobs, you don't like the programming yourself, but it's good to have some understanding of what's going on so that you can, have more of an interaction with your staff who are doing the IT work. So if you're interested in pursuing a more technical direction in your future career, then this course offers you a nice opportunity to add to your portfolio. So if you're going to a job interview and they're saying, oh, you know, let's say for a Java developer, and they say, oh, you know, what have you done, right? They're going to ask you, you know, what's your actual concrete experience? Well, on this course, you're going to develop a website with web services, cloud data storage, and third-party scraping of data. So that's the sort of thing you can show to an employer and say, well, look, here, I developed this, and these are my skills that I gained through developing that. Or, you know, you're also going to get experience building an online game, so then you can say to the employer, well, look, here's my online game. It's got this beautiful interface. It's fun to play, and it's based on sockets. And I did, you know, this bit of work, and it also displays how I can work successfully in a team. So these mini projects could form a key part of your portfolio. So you might be worth bearing that in mind if you've got an interest in working in the technical world. Resources. So we've got lots of resources for this course, of which this video is one resource. So we've got lecture videos. I can't remember how many there are likely to be. There'd like to be 25, 30 lecture videos, something like that. Some are really short, as you probably already realized, but some will be much longer. So the advantage of this flipped classroom model is that I can have little short videos on particular topics, but also have more extended ones as well. So you've got all the lecture videos. I'll make all the slides available online, obviously. I've put a lot of links to online resources on the course website, so you can follow up, find out more things, tutorials, that kind of stuff. There will also be detailed descriptions of the coursework for each of the pieces of coursework and some example code. So if I give you a lecture on servlets, let's say, I'll give you a piece of example code that you can run and see how it works by yourself and during the labs, obviously. So do let me know if you can't access the lecture videos, for example, or you're struggling to get the example code working, or any other problems with the resources, and I'll do my best to help. So this is like the course website in the first year. So you've got the different, these are the courseworks with the description. In this case, these description and assessment criteria merged, the submission link, and maybe an assessment schedule, this kind of stuff. So that's the sort of descriptions of the different types of coursework. And then for each week, I'll make available the lecture videos, and also this is like a bunch of different this is on peer-to-peer networks. So there'll be the lecture slides there, there'll be a link to the videos, but there'll also be all these kind of links to different papers on the topic, or online articles, or anything that you might find useful if you want to find out more about the topic. I'm more than happy to make resources available in other formats. So, for example, if you have issues with dyslexia, I can make the resources available in open dyslexic fonts. Or if you've got visual impairments, then I'm more than happy to have a discussion about the ideal sets of colors to help you to access the resources more easily. Most important thing is, if you've got special requirements, do come and see me. I'm more than happy to discuss your issues and do the best that I can to address them. So reading. Okay, so we've got a reading list on the course website, and we've got this free electronic textbook. So there's the reading list. So we've got the sort of essential stuff and then the sort of recommended stuff. These two books here. We've got Distributed and Cloud Computing and Distributed Systems. So this is the main course book. This is the book that I've made available as a free electronic textbook. Now, to be honest with you, I mean, this book is covers. The reason I picked this book is because it covers pretty much everything in this course to some extent. So it's a good resource for covering all the material. That's the good point. That's why I picked it. On the bad point, it's actually quite badly written, and there's a lot of stuff that's a bit crufty and useless, to be quite frank with you. So although it's the course book, I'll give you some references to chapters which are worth looking at. It's worth reading bits of it. I'm not recommending it as a great work of modern computer science textbooks. It's not great, but it's got lots of useful, relevant information, so it's worth having as a free electronic textbook. Now this one's a bit better written. It's probably a bit more popular, I imagine, but it's got less overlap with the course. But the bits that do overlap with the course are useful and well worth looking at. And you can borrow this from the library. It's got tons of copies, so it's also freely available to you, just in a slightly different format. Then we got the recommended reading list. So this course has a reading list, but as I said earlier, I mean, most of the really useful and interesting stuff you'll find in the links on each week. So this is where you'll find all the up-to-date articles, recent papers, all this kind of stuff. The reading list might provide you with some useful starting points Come on. But, you know, some of these books are a little bit out of date, and some of these books I haven't used myself because, you know, they're there. It might be a place to look if you're struggling with some particular thing, like if you're struggling with Java or something, then there's a decent Java book there, and there's some stuff on network programming and so on and so forth. But I wouldn't recommend that you start with the reading list. I recommend you look through all the other resources, and if you still need some help, then have a little look through the reading list and see if there's something useful there. Okay, so cover that. Okay, so timetable. So I don't know the exact timetable, but you know, one thing's for sure, it's going to be taught in this kind of way. So we've got this lecture, which is not going to be part of the scheduled time. It'll be a variable length and it'll be distributed online. And I'm expecting you to watch that lecture prior to the seminar, which will be 1 hour seminar each week. And then we've got the 2 hours of lab session every day, 2 hours labs each week. And then we got it after the Easter break, we're going to have revision sessions to help you with the exam. So in the autumn term, we're going to cover a bunch of topics. We're going to cover HTTP, domain name system, web services, cloud data storage, commercial websites, peer-to-peer networks, security, privacy, and legal issues. And I'm going to say a little bit about online games to help you with your project in the spring term. In the spring term, we've got some stuff on socket programming, threads, how to build an online game, WebSockets, media streaming, cryptocurrency, and some of these big sort of enterprise stuff in Java, like remote procedure calls, Java messaging services, and a little bit on big data processing and the Internet of Things. So the lectures are, what the lectures are going to do is give you information about the course, as I'm doing now, and so there'll be lectures on the different mini projects and the coursework you've got to do. And these lectures are going to give you, also, there'll be lectures that will give you the high-level understanding of internet scale applications with some case studies. So, for example, in the lecture on peer-to-peer networks, I'll give you a little bit of a high-level stuff about peer-to-peer networks, a little bit of architecture stuff, and then we'll go into details of how Freenet and BitTorrent actually work. So the idea of the lecture is to impart knowledge and help you understand how these internet scale applications work. So lectures will also give you technical information that will help you with your coursework. So I'll explain in detail, for example, how sockets work, explain in detail how threads work, and that'll help you build a multi-threaded game that communicates with sockets. So the high-level understanding will help you with your class presentations, with your essay, and with the exam, and the technical information is designed to help you with your mini project. Then during the seminars, one of the aims of the seminars is to be able to answer questions about the lectures and the coursework that you're having, maybe explain things in a little bit more detail. What we're not going to do in the seminar is sit and watch this video, right? You're going to watch the video before the seminar, ideally, and then we're going to have a conversation about the video during the seminar. We're not going to sit there, you know, watching videos of me talking to you, no chance. So we're going to have some group work as well. So, you know, different exercises to help you understand some of the internet scale applications. We're going to throw in a couple of quizzes, one at the end of the autumn term, one at the end of the spring term. And beginning of the spring term, we're going to have class presentations, which you're going to give to explain to the rest of the group how particular internet scale applications work. Then during the laboratory sessions, the idea is we're going to sort of split the term into 2 halves. So in the first half of the autumn term, we're going to have laboratory sessions dedicated to giving you exercises, first-hand practice with the internet, with the technologies that you're going to need for your mini projects. So we're going to have going to follow some tutorials on HTML, CSS, JavaScript, Ajax, servlets, and data storage with Amazon. So you follow these tutorials, get familiar, comfortable with the technologies, and then the second half of each term, you'll then apply those technologies in a staged way in order to develop your mini projects. Obviously, you're also going to need to spend your own time in your mini projects. You'll have maybe 10 hours of labs actually explicitly dedicated to the mini projects. You're going to have to spend your own time, look into it yourself, and spend your own time working on that. In this course, I'm expecting you to have a reasonable level of Java, not necessarily whiz kids on Java, but capable of writing some basic code in Java. Development environment will be NetBeans and Chrome, and I'm going to give you time to follow tutorials on HTML, CSS, and JavaScript, but I'm not going to give you any lectures on that, right? It's a bit basic for this course. It's something that's very easier to learn anyway, just by following tutorials online, than me lecturing you about, how to add a link in HTML. as I said, lots of tutorials and support in the laboratory sessions, and there are extra Java sessions available. So Middlesex has a mechanism, or some kind of catch-up Java sessions, I think they're called. So do get in touch if you'd like a bit more practice with Java, and then I can direct you to these courses when they're announced. Above all, this is your course, right? I'm not doing this, just for my own pleasure, right? The idea is for me to help you to learn about internet scale applications. So if you're finding things difficult, if parts of the course don't work, if you find it's completely obscure and meaningless to you, then do come and see me. We can have a conversation about it. Talk to me at a seminar, laboratory session, drop me an email, come to see me by appointment, and we can have a conversation about how the course can be made better, which will benefit everyone, and maybe I can help you to address the particular issues that you're having with this course. Okay, assessment. So we've got a sort of series of assessments spread out over the entire year. So the autumn term, we got the mini project, the first mini project. I'm going to talk about all these in detail. So in this lecture, I'm just going to give you a little overview of each of these, and then there'll be a lecture dedicated, recorded lecture dedicated to each of these four. I'm not going to have one on the exam. So the first one, autumn term, website. Second term, spring term, online game. Then we've got an essay and a class presentation on the same topic in the spring term. At the end of the course, it'll be the exam. And you must get at least 40% in both the coursework and the exam in order to pass the module. It's crucial that you bear this in mind. I think the coursework's fairly easy to pass, but the exam is less easy to pass. First year I ran it, I think 4 people failed the exam, something like that. And then they had all the wearisome business of turning up again, doing all the revision again, just sitting through the resets and all the rest of it. So I strongly recommend that you take this seriously and make sure that you can pass. You need 40% in both, and to get that 40% in the exam, you're going to have to spend some time watching these videos and understanding the material. Okay, so first mini project, this, as I said, is just a brief overview. We've got a whole lecture on this with some examples. So the first mini project, 20% of the mark, it's an individual project, and you're going to build a website based upon web services written in Java, third-party data, access from a website or web services, and data storage in the cloud. Deadline's the end of the autumn term. More information in the next lecture. Mini project 2 would be a group project with the groups allocated at random. It'll be an online game played by 1 or 2 or more people, played on different computers, based around TCP, UDP socket programming, or maybe an equivalent technology. And deadline will be sometime in week 23. The full details will be announced on the course website. Then we've got the essay, which is 10%, 4,000 words, and it'll be a description of internet scale application with illustrations of the architecture, so maybe an essay on Google, essay on Freenet, essay on an online game, and so on. So how this works is there'll be I've got 20 topics, there'll be a quiz at the end of the autumn term, and the person who comes first in the quiz will have first choice topic, person who comes second, second choice topic, and so on. Deadline for the essay is the end of week 17. And class presentations, they're going to be on the same topic as the essay. You're going to give a short 5-10 minute presentation to the rest of the class during the first half of the spring term. Then the exam, there'll be, you have to answer 3 out of 5 questions, I think. And there'll be sort of factual, technical questions about all the material in the course, and that's why watching the videos online is going to be helpful for you. Date and time to be confirmed. So it's a general way in which I run this course. I'm not a big fan of deadlines and excuses, okay? So I'm very unlikely to accept excuses. I strongly recommend you hand coursework on time, and I strongly recommend that you contact me before the deadline if you run into particular issues, okay? Under some circumstances, I might give you a little bit of extra time if it's very convincing, but if you contact me after and said, oh, well, I forgot, or I fell asleep or something, then I'm just probably going to ignore you, okay? So, unless I've given you permission for late submission, the marks available for coursework will halve every 24 hours after the deadline and will hit 0 after 1 week. This is a generous, warm-hearted policy on my part because the university as a whole does not support the idea of giving extensions at all, right? They just like flat, hit 0 after 1 second, So here you are with this warm, fuzzy policy of hitting 0 after 1 week, but I will stick to it, so I strongly recommend that you contact me or hand your coursework in on time. However, the university also recognizes, and I recognize as well, right, that sometimes you've got, overwhelming personal problems that interfere with your ability to study on this course. And university and myself are more than happy to take that into account, right? What you can do if you have, if you're ill, if you have serious personal issues, if someone close to you is ill or dies or something like that, then you can apply for what's called a deferral of assessment. This gives you extra time to complete coursework or retake the exam. It has no mark penalty, and this is what I strongly recommend that you do if you do run into personal issues. Because even if you do manage to hand the coursework in, maybe you haven't given it your best effort, and this doesn't have a mark penalty. I don't think it even appears on your university record. It's, it's just to help you, really. So do look at the documentation there. So, if you're running close to the deadline, you're having strong, serious personal issues, come and see me, and we can talk about how you can apply for deferral of assessment. But you do have to provide documentary evidence, all right? So there's no point in making something up. You're going to have to prove it. Okay. So this lecture has just been a little sort of overview of the course, the resources, how it's taught, all this kind of stuff. Covered the contents of the course, the resources available, how it's going to be assessed. And now the next lecture is going to cover the first assignment in more detail. I think when you've got a good understanding of the first assignment, then you'll see how the first half of term is going to work and how it'll start to make a little bit more sense to you.